Okay, we look at another example. Let's take this R X E X Y D A, and here we say R is between 1 2 cross 0 1. 1 2 cross 0 1. Okay. Okay. Now, if you must understand integration, okay, to be able to see that, okay, like sometimes it's more easier or simpler to integrate with respect to one variable before the other, right? Looking at this question here, I would say that it will be easier for me to integrate with respect to y before x. Now for that, we don't teach. You must understand integration. Okay, so hey, take integration serious. Now because I'll be integrating first with respect to y before x, if I do with respect to x before y, I must get the same answer, right? But sometimes it's impossible to first integrate with respect to a particular variable, right? And all is integration, and we'll get there. We'll see some. Good. But for this one, I will have to integrate this first with respect to y before x. So I write 0 1 minus 1 2. Now if I integrate this with respect to y, I'm going to get ex y x over x. Okay, I'm not seeing integration, so you must understand. Okay, let me keep it in. When I integrate the e, this when I integrate the e function, I'm going to get the same thing, exy, right? I differentiate what is here, I get x with respect to y, it comes to divide, it will cancel the x. So I have this at 0 and 1. I integrate this like that. So first I put 1 in place of y, and I'm going to get ex minus, when I put 0 in place of y, I'll get 0 on top. E to the power 0 is 1. So actually I'm integrating this now from minus 1 to 2. Okay, yes. When I integrate ex, I get the same, respect to x, I get the same thing, ex. When I integrate 1, I get x. Now this at minus 1 and 2. So I put 2 in place of x, and I'm going to get e2 minus 2 minus, when I put minus 1, I'll get e minus 1 plus 1. Okay, and I simplify this, and I would have e minus 2 minus e minus 1 minus 3. Okay, now this has been nicely solved, right, on the slide, so it should not be a problem. You must just understand how it is done. And there are several examples. It is not really a problem to integrate over a rectangular region. Okay, a difficulty arises when we have to integrate over a general region. Okay, so let's look at the prereqs of this kind of integration. Double integral over a general region. If it's a general region, okay, Then because it's a general region, if I decide to integrate with respect to y before x, remember, general region means that here is not a rectangle. The region is general. Okay, it's general. Okay. Now, if I decide to integrate with respect to y, right, then the inner limit here must be functions of x. So I'm going to write here h1 of x and here h2 of x. Note the outer integral, the one corresponding to the outer one, they are always numbers. So let's write here a and b. Next, if I decide to integrate first with respect to x before y, then the inner integral must be functions of y. And the outer ones, always numbers. Now if you can see, I use a, b, and here c and d. I'm just showing you that it is not as easy as a rectangular one, where we just swap and swap. Right? Okay, we don't just swap. You will soon see how it is done. Okay, but I would want to emphasize, do some emphasis here. Let me clean your room so that you understand clearly. Assuming I have f of x, y, z, w, dw, dz, dy, dx. Okay. Now, because this dw here corresponds to the inner integral, right? Now, the limit here should be function of x, y, and z without w. W can be part of it, right? So I'm going to write here g1 of x, y, z, and here g2 of x, y, z. Okay. Then next I come here now. This one here corresponds to z. Remember, w has been taken care of. So z must also, the limit of z must also be functions of only y and x. So I'm going to write here h1 of y, x and y, sorry. And here h2 of x and y. Okay. Now I come to y. W and z are gone. So y here must also be a function of only x. K1 of x and K2 of x. The last but not the least, the outer ones are always numbers. So A and B. You must understand this basic principle before we start to integrate. Now, the problem with multiple integral is finding the limits. Finding the limits. We are going to see how to find limits of multiple integral. In any case, let me just solve a straight one for you to see. Since I just have time. We are not going to focus on the integration. The integration will be fine. Take care of that one. Here, we are going to find, our objective is just to find limit. So assuming you've been given this to do 0 to 1, here is x and here is x squared of 2y dy of 2x dy dx. Let's say we are doing this, right? So first, I integrate with respect to y of this function. I'm going to get 2xy. In place of y now, I put x and s squared and integrate from 0 to 1. Dx now. Now when I put x here, s squared here, I'm going to get 2s cubed minus, when I put x here, I get 2x squared. This is what I'm integrating from 0 to 1 dx. If I integrate this, I get s to the power 4 minus 2 over 3 x to the power 3. Now, the limits are 0 and 1. When I put 1 through this, I'm going to get, when I put 1 here and put 1 there, right, I'll get 1 minus 2 over 3 minus, when I put 0 inside there, I'll get what? 0. Now this and that is 1 over 3. So eventually, I get 1 over 3 as an answer. Okay, it's a very simple exercise. There is no big deal. As I said, if you have problems, you can book appointment with me for more clarification. The last time I told you to call me, so far nobody have called me to say anything. So I'm just hoping you are fine. Okay. Let's move on.